But there are some cases where this bridge logic can be brought even further. And that's where we get into mesh, where basically it's a bridged role, but instead of having just 2 or 3, you may have plenty of access points. And one strength of this logic is that you say, I'm going to decide that some of these access points, maybe more than one, will have a connection to the wired network. Let's say these 2. And the others may or may not have communication with the wired network. But we are going to configure them so that it doesn't matter. If they have communication to the wired network, they will be using that wired communication. But if they do not have communication through the wired network, they are going to use their radio to find some other access points that have a path to one of the access points that have a wired network communication. So you're going to create a sort of mesh communication between these APs and those that have a wired network connection. It's a configuration logic because the ones that have a wired connection must use their wired connection if they are configured to do so. And some other access points will be set to say, you are flexible. If you have that wired communication, you're welcome to use it. But if you don't have it, then use your radio to jump across one or maybe many antennas until you find one access point that has this wired connection. The role is set, and these access points that have wired connection and must use it are called RAP, root access points. All the others that may or may not have this wired connection and are free to use the radio are called mesh access points or MAPs. This has been growing in popularity. It's something you find not only in large municipal environments where large cities have large networks of mesh access points that provide Wi-Fi connection throughout the entire municipality, but that's also something you find also in smaller environments. For example, a business with an outdoor area for storage where you want to extend the indoor network outside and you're going to use a small mesh network to provide that coverage. Or a shopping mall where coverage is provided on the parking lot to many customers parking their car. And of course, because there are many use cases, there are many protocols that can be used in this type of environment. Cisco uses one protocol that was developed long ago that is called Cisco Adaptive Wireless Patch Protocol, AWPP. I mentioned this long ago not to say that this protocol is old, but to say that it's been there for a while, more than a decade now, more than 10 years. In between, the IEEE was also working on the protocol for mesh network, and that came out as 802.11s a few years ago. You may hear about 802.11s, but it's not as widespread as a vendor proprietary protocol like AWPP. And the reason why is because 11s took about 7 years in the making, in between which vendors like Cisco built their protocol, deployed their network, and now they don't have any real reason to go back to undo what they did to invent a new compatibility with the protocol that's there. So Cisco networks today in mesh use AWPP, and of course today, the industry will be starting to adopt 802.11s widely, maybe through Wi-Fi Alliance certification, who knows? Well, that day maybe Cisco will change from AWPP to 11s, but until then, in a Cisco network, AWPP will be the protocol you find in mesh networks.